Hi, Gators. I'm George Delagrammatikas, and I'm a professor of mechanical engineering and material science at Duke University. I'm also a very proud Gator dad to Zachary and Yanni. It's such a pleasure to join you today as we celebrate your great science fair work. Not only were you learning about something that you were genuinely interested in, but you were developing skills that are going to be important in your success in whatever you decide to do in the future. First off, you wouldn't be here if you weren't curious about something. Don't ever stop asking questions about the world around you. Throughout your lives, you're going to encounter many problems. Some will be really easy to solve, and some are not going to be so easy to solve. What a science fair project does is it trains you to figure out how to tackle these really hard problems. And these projects also teach you that you should never give up. This is called perseverance. What you also get to appreciate is that you should never stop learning throughout your life. Don't ever stop learning. You will actually turn into your own best teacher as you grow older. For me, science is just another way of looking at the world around you to try to understand it. We use mathematics as the language that translates what we see outside in the real world into something that we can understand and that we can predict. Engineers are people who take the math and the science and use it to solve really big, important problems that ultimately make the world a better place. And technology, those are the tools that engineers come up with to solve these big problems. Now, these don't mean anything unless we also include the humanities, social studies, art, music, language, so that you become a very well-rounded, good citizen. And that's what your teachers at Alston Ridge are trying to do with you. I wanted to show you what my students do to show off their work, much like your science fair. They go to conferences with posters and they answer questions that are asked by people who are walking by. This should look very familiar to you. As you present your work to others, you get questions from people that you'd never thought of before. And it's these questions that help you better understand the project you just did. As a scientist, it's important to show your work off to others. It's this knowledge that you need to share with the world. At Duke and at all universities, we do some really incredible stuff that almost sounds like science fiction to me. We build robots that perform surgeries on people. We build really fast cars that don't pollute. And we even make machines that learn on their own, almost like human beings. We also build using modern machines like 3D printers and laser cutters, and we perform experiments all the time. Engineers try to help people live better lives. When I was a little younger than you, I remember that I had a little tricycle, and my father gave me a toolkit at the same time. I used to take the tricycle apart and put it back together all the time, every day. I must have been 5 years old. I appreciated working with my hands and taking things apart, and sometimes I was able to put things back together. I later became very interested in light. When I started experimenting with magnifying glasses, I learned about heat, energy, and transferring these different light into heat and energy. And just make sure that when you experiment with magnifying glasses that you always have adult supervision. My engineering understanding grew even more when my father took me to this ship. This must have been 40 years ago. And he took me into the engine room. And I was amazed to see machines, the engine that was so huge and so loud and so powerful. I just fell in love with it. And then later at the end of elementary school, I saw these pictures, and then I fell in love with light and photography. And how do you stop something in midair like that and take a picture of it? It was just astonishing to me. Later in junior high school, I learned about this car that went across Australia just on solar power, and I was hooked. I needed to build a car just like that, and I needed to race this thing just on solar power. And I lived my dream in college, where I designed and built the insides of this car that we raced across the United States. So now my curiosity continues, and I like to solve all sorts of problems. Now what I do is I build robots with my students, and I continue to learn. They're the ones who are teaching me. They're the ones bringing these great ideas to the classroom and to the laboratory that I've never thought of before. And so we're programming computers, we're building robots, we're learning how to use scientific knowledge to design things that help people out. And it's never too young to learn. And you see this little guy right here, you might recognize him building his first robot from scratch. I wanted to end today's talk with the first question that I asked for a science fair project. This was in the 7th grade. Now, my first science fair was in the 7th grade. Yours was much younger than me. You guys are much further ahead of me than I was. And in the 7th grade, I wanted to find out, why is it that moss grows on the north side of trees? And immediately when you think of something like that, you think, well, the earth has a north pole and a south pole, and moss has to clearly grow on the north side because moss likes the north side of magnets. That's what I thought. I did my experiments, nothing worked out. I presented my poster at a science fair, and then the judges, who were both science teachers and professors from local universities, they came in and they pointed out all my mistakes. They said that your conclusions are wrong, that even your experimental control was set up incorrectly, and the data graphs that you showed, you didn't show them properly. What I learned was much more than about moss. And the reason that moss grows on the north side is because it's the shaded side of the tree in the northern hemisphere. There's not enough water for moss to grow there. And so I learned a lot from the project, not about the moss, but more about how to make a better experimental control, how to think more clearly about a problem, and also how to make sure to present things in a way that are clear for others to understand them. That's the whole point behind the science fair. It's to teach and to learn and to spread knowledge. So I also wanted to end the story because of the reason that I picked this problem. And at the same time, in the 7th grade, the period before my science class was my social studies class. And my teacher there was talking to us about a woman known as Harriet Tubman, who you have probably heard about in your breakfast biographies. Now, Harriet Tubman, also known as Grandma Moses, was the one who used the Underground Railroad and brought slaves from the South to the North to freedom. And the reason that this problem stuck out with me with this moss is that the slaves were traveling at night, so they wouldn't get caught. And the only way that they knew how to go north was to look at the North Star. And if it was cloudy, they would go to trees and look at where the moss was. And they used to use that moss to find the direction north. So that's, even though this is a science fair project, it really brings you into understanding the human side of things, about how biology had actually helped people to freedom. So thank you all for listening. I hope my stories inspired you, and I hope I get a chance to see each and every one of you at Duke very soon. Maybe when the pandemic lets up, you could come for a trip and I could show you through my lab, and we could start running experiments and running robots together. I think we'd have a lot of fun and you'd be inspired to do a lot of things. So thank you for having me, and I hope you have a terrific science fair, everyone.